Let me start off with a quick story. We were doing some kind of context mapping session. I was teaching a workshop, and one of the domains that we were doing was somebody who works for funeral insurance. So what they do basically is you pay monthly fees, and when you pass away, it pays for your funeral. And then, of course, they talk to your family, and they upsell you better service and better coffin and all of that stuff. And so we were sort of modeling this and looking at languages and contexts. And at some point, this person said, actually, it's two different things. It's as long as you're sort of paying your fees, you're a customer. And then there's basically this, transition event, and then you become the product, right? And so basically now you understand what bounded contexts are. It's the same thing, it's a different language, so maybe we need to separate this. So maybe I should introduce myself first. I'm Mathias Verraes from Belgium, as you already said. I organize Domain-Driven Design Europe in Amsterdam in January next year. And I consult for organizations, any size really, doing modeling and strategy, architecture, that sort of thing. So living the DDD life, so to speak. So let's see, who here has experience doing domain-driven design? Excellent. And who is doing like context mapping and bounded context and sort of applying that? Excellent. Okay. So that's what we're going to talk about. I think this is, first of all, I think this is one of the most important innovations that DDD did or started doing back in 2003. This very idea of basically every company I've been to that has a certain size and a certain age. At some point, they brought all the architects together and said, this thing is a mess, all these systems and all these languages and all these models, let's fix it, right? Let's build this one big universal model, one language that will solve all our problems. They put all these people, like all the architects, 6 months in a committee or 18 months or whatever, and they come out with this big document, and it doesn't work. So what do you do when it doesn't work? Well, you do more of it, or every 10 years they try again. And I think DDD, as far as I know, is the first to say this doesn't work. Let's do the opposite thing. Let's not make this one big universal language. Let's accept that human languages are messy and have nuance and have duplication and have all these things, and let's just make some boundaries for it. Let's enclose this and say, well, here at least we can do this little clean thing and have a language that we agree on, and we're not trying to be consistent with the other ones. So this is, I haven't found any other sort of discipline that is trying to do this or that makes this. The other things that you'll find them elsewhere, like look at the domain. People in other disciplines have been saying this, or modeling is not a new invention. But this aspect, I think, of DDD is one of the sort of almost counterintuitive innovations. So when I talk to people, they always seem to believe that bounded contexts are systems. So it's not a system. It's not a physical system. It's not a microservice. It's not some technical boundary. It's definitely not a team boundary, even though often it matches, right? If you have a single language that's going to usually grow in the same, in your social circle, which is your team or your department maybe. But I wouldn't use that as our primary sort of heuristic for finding these bounded contexts. Another thing that I believe people are getting wrong a lot, all the time really, is confusing bounded contexts with domains. So your domains are basically the problem space. It's what's given to us. I work in logistics, or we work in public transport. That's our domain, and then we have all these subdomains, etc. in there. But those are not contexts. The contexts are your world. That's the solution space. That's you as a system designer are responsible for deciding on these contexts. And this seems a bit hard to understand for people, that we're drawing these boundaries and that they're almost invisible unless we start actually agreeing on them and documenting them. But naturally, when we say, here's a language and here is sort of the same language, that's not the way we're used to thinking about systems. We're used to thinking about a system as maybe a single deployable unit, or a GitHub repository, that's a system, or something that sits on a single server, that's a system. So that's sort of the area that we're interested in. So this is why I think the little story of the customer becoming the product after passing away, I think that's a nice example to keep in the back of your head whenever you get confused about bounded context. So and one other thing I've noticed going to all these different places is that, well, one of them is that almost every team believes they're working on the core domain. They're not. I'm sorry to disappoint you, but sometimes there is not even a core domain. I mean, there is a core domain, of course, but it might not be in the software. Maybe it's people out there on the floor doing things that you just can't do in software, or people in the field. Maybe it's very sales-centric, and it's just the people being there and selling stuff. That's your core domain. That's not the thing you're modeling. So everything else you're building is just subdomains. But what this talk is about is whenever I go somewhere, so it's sort of changed. It used to be that it was one person trying to push DDD, and nobody else in the company had heard of it, and they're trying to bring me in to help spread this idea. And the last 2 years or so, this has evolved a bit, and it's a couple of people already doing it, and they made some progress, and so that's DDD is getting adoption. But I come there on the first day, and maybe it's like a new project or a new thing that they're going to do, fully DDD, and on day one they say, well, we have these 3 bounded contexts. Well, you already know this up front. That's that would be nice if that was true, and it's always very, very clean. So I'm going to try to illustrate with a somewhat, based on reality, but an example of a domain. I'm going to try to illustrate how that doesn't really work. So let's, and by the way, this is a whiteboard session, so feel free to shout things and ask questions, etc. throughout. It doesn't have to be like a one-directional presentation. So let's go into the domain of plumbers logistics. If you don't know what it is, ask Eric. You don't remember? I'll refresh your memory later. So we're in plumbers logistics. So we have a warehouse basically, and we need to build some software for that. And so it's day one, and people say, "Okay, how does a warehouse work?" Well, it's quite simple, really. It's we have receiving. It's stuff coming in off the trucks. So we unload the plumbuses, and we have to mark them on some receipts, and then we have to put them somewhere. So this is put away. Put them in the right locations in the warehouse, and then at some point, of course, they need to go out. Somebody ordered them, and we have to put them in, package them, maybe put them in trucks, and that's put away. And this is our. This seems so. This is nice, right? We can draw a little bounded context here, and at the end, they're nice, processes within the life cycle. At some point, this process ends, right? So we probably have a little event going over saying, we're done. It's ready now for put away, and then another event going here, or maybe this comes from some ordering system. But it seems like we can nicely separate this. So this might be a good candidate for our bounded context. So we need to start adding things, of course. So this looks nice and clean, and then we get, we start talking, or we start building or adding stuff. And one of the first things we're going to have to do is probably order picking. So I imagine that's going here, right? So it's people who walk around and have to get the stuff from the warehouse. And so there's the next concept in our model that is going to get some prominence is, well, where can I find the thing? Where can I find the plumbus? So that's locations. And already this is putting some pressure on our boundaries because, well, if we have to know where to get it, we have to know where to put it first, right? So is this, where do we put location? Do we have it in both of these? And people start yelling, don't repeat yourself. There's always this nagging voice of somebody saying, don't repeat yourself. We can't have the same concept twice. Yes, we can. That's why we have bounded context, so we don't have to worry about this problem. But eventually there's some agreement that let's make it a shared kernel, right? That solves it. And that's, it's probably even fine, but how long is this, like, if everything ends up in your shared kernel, let's call it a monolith then, right? So it's putting some pressure on the model. And and this is maybe a bit of a problem with Agile, I guess, that we're so focused on doing small bits and some new feature requests. We take like a couple of feature requests and we do a sprint for it and we ignore the future and then we move on and we do it again and again, which is, I like that as an approach, but the risk is that it sort of blinds us, that we don't really see how stuff is going to get coupled in the future. And I'm not advocating big design up front, quite the opposite. And DDD is definitely not about big design up front. It's not about doing this big speculative analysis up front and making your whole design and then just handing it over and implementing it. But I think that Agile sort of swung the pendulum too much towards no design up front. So what I'm saying is do a little bit of design up front, but most importantly, do some discovery up front. Like spend some time on the whiteboard and running through scenarios and trying to think, okay, but what are we going to need in the future to do this thing? Even then you'll be wrong, but at least you have some idea of sort of the space you're working in, right? So I call this putting pressure on the model. Sometimes I like to go through all the scenarios where something can go wrong, and people say, well, that's an edge case. That will never happen. That will happen like 1 in a billion times. And they're probably right. But there's still a good reason to go through these scenarios, because it sort of pushes your model and well, I don't have another word for it. Just puts pressure on it to see if, well, if we cared about this, if this moved from being an edge case that never happens to something that happens all the time, would we still be able to adjust it? Yeah. Are we looking at this from the right point of view? So of course, this is not this is like a very minimal warehouse management system. If you don't have this, then you don't even have a seat at the table. Of course, you have to. This is the absolute minimum for every warehouse system in the world. But then, of course, people start. Let's say we're building maybe a SaaS for these kind of things, where different, not just Plumbus logistics, but different people are starting to use it. What kind of competitive advantages would we have? What kind of unique selling propositions would we have? So in one client where I worked on something like this, they started optimizing for order picking. And so how do you optimize for order picking? Well, one of them is reducing the walking distance of the order pickers. So if you have to walk, if I have to walk to the back of the warehouse, fetch something, walk all the way back, and then the next time again go all the way there, and I have to do this 20 times a day, that's going to be more expensive than if that thing that I need 20 times a day is near where I need to be. So we need to sort of start optimizing for the order pickers. So superficially, we would put it here because it belongs to order picking. But of course, it's not just, well, there's a couple of things we can do. We can do it very locally here in the sense that if we can sort of look at multiple orders at the same time and say, instead of, here's an order, pick all the things, come back, here's your next order, we can sort of batch this and say, well, we have 5 orders that need something from this area, so go there first, grab those things, then go there, grab those 5 things, and then we sort them out. Maybe that's more efficient. So if that's all we're doing, we could sort of do this quite locally here, and it would fit in this bounded context here. But what really happens is, the more interesting thing is sort of making sure that these walking distances themselves are very short for the products that we need to grab the most, right? So, and that means that we have to put them somewhere in an optimized fashion. So this would be somewhere here. So this is sort of coupled between put away and receiving here, right? So our boundary is, you see how quickly this boundary is starting to disappear. In reality, of course, this could take a couple of months or even years before it's starting to become a problem. But it's, so yeah, maybe I should put this one on there as well. So it's allocation. In order to optimize the walking distance for the order pickers, we need to allocate items to the right place, not just put it anywhere, but this product needs to be close to the exit. This product can be distant because we don't need it very often. So, and this is sort of a pattern, and sort of emergent pattern that you see in this kind of, in any kind of system, really. I think it's a very common thing where it starts as humans optimizing. So it starts with somebody working there. Maybe it's a manager, or maybe it's even the order picker himself who says, well, I have to walk this distance twice because I have this order and this order that also needs that product. And they start optimizing themselves, right? This is usually how it starts, very often, where it's just sort of humans trying, they're under pressure to deliver and to finish their work in time. So they start to find little ways where they batch stuff and they talk to their colleagues and say, oh, you need 5 of those and you need 5 of those too. Well, I need to go there anyway, I'll bring them for you, right? So that's usually how it starts. And then typically management finds out because stuff starts going wrong because these people are optimizing, but they don't have the full picture, right? They're sort of trying to optimize from within the system without sort of seeing the whole thing. So that's typically when you start looking at, well, can't we just automate this kind of thing? Can't we just detect upfront or do some forecasting, really? So that, well, where does that go? Because basically I want to know, for example, if this product comes in at 8 in the morning, there's a high chance that I will need to take it out again at 12 noon. So if you can predict this kind of thing more or less reliably, then you can start optimizing for it, obviously. So of course, in order to do that, we need to understand more about the actual orders, which let's assume they were happening somewhere else. Maybe we have some ERP system or something that deals with the orders. But now we need to know about the orders in order to do forecasting and to decide where to put something so that later on we can pick it in a sort of optimized way, right? So, so I think this is sort of the part of this this pattern where it starts with humans optimizing, it evolves into automating that, and then that very quickly leads to sort of coupling between areas that previously we thought were nicely separated. We thought it was a process that ends, and a process that ends, and now it turns out that it's all sort of interconnected and trying to look at the future and that sort of thing. So, but maybe we're not in trouble yet. It would have been nice if this was somewhat different, but it works. There's actually, by the way, a good example here of how domain-driven design can actually help you get a competitive advantage. Maybe we thought our core domain was doing this sort of, the basic logistics of warehouses. But so the client I was mentioning, what happened with them was we actually managed to start separating the sort of forecasting and the order picking. We actually turned that into a bounded context itself. So it became something more like, let's say this, and the walking distances. And we started basically separating this into its own bounded context. And it was far from ideal, it wasn't perfect, but at least we could start to reason about this thing in isolation without being coupled to these things. And then what happened, that was the interesting thing, that company's core domain shifted from doing this stuff that everybody else is also doing to providing this thing as sort of a plugin or a service to all the other ones. So instead of going there and buying their whole solution just because you like that, even though this one maybe doesn't work for you. So now they could start selling this as a separate product without you having to switch to this one. So suddenly their market opened to a whole different set of customers that they usually wouldn't have been able to get, thanks to this sort of separation and decoupling. So that's sort of the shift I'm trying to suggest here. That your our original bounded contexts were very sort of based on perhaps naive perception of how the domain is structured and what our subdomains are, and just mapping sort of context to domains. Here we're saying, well, if this is so important for us and this is less important, then maybe this is our core domain. So maybe this should be a separate bounded context. So maybe when we do that, we can start, because it's isolated, we can put all our effort here. This could be still, or maybe our old CRUD system, but this one is where we start doing, lots of conversations and going to the workflow and look to the workflow and talking to people and like put all the work there and just optimize for this. So that's sort of what I'm trying to get at. That context can be, instead of this sort of vertical separation, that you can take a whole different view of them and extract that and make that your sort of focus. But let's imagine we haven't done this maybe, and go back to our previous mess. So this is happening somewhere, and this is maybe here. And more stuff needs to be added. We're back in Plumbus logistics. Maybe there's some what I call value-added operations, right? So that could be that's typically stuff like cutting the product up if our customers don't want to buy the whole Plumbus but just a part of it. That's probably something we're going to do here. Could be stuff like opening the box, adding a manual depending on. It's an English manual or a Spanish manual, that sort of thing. That's typically stuff that happens in not in manufacturing, but in the warehouses, right? And then, of course, typically people are in a hurry. They're always in a hurry. All businesses are always in a hurry. So we need something specific for that, which is expedites, which is probably going to be, well, here's the problem. Naively, we could say, so expedites is somebody calls and says, well, this thing needs to go out really, really soon. Or we're losing this customer, or some bad things happen. So, and again, it starts as one of these things where it's just sort of people in the system finding their own workarounds. Like, we're supposed to do this process, but somebody called from the office and said, we have to do it now. So we're skipping some things, and I know that if you click this button and then set it to that state, and then you can actually move it through the system faster. So what's starting to happen is not just expedites happening here, where an order comes in and we're order picking it and doing that faster. But it already starts here, where somebody says, well, that product needs to go out very quickly. It's not here yet. Oh, the truck is arriving. Let me just grab it, bypass the whole process, and put it in the other truck to go out straight away. Yeah? Or even have like a courier service or whatever. So again, it's one of those things where all the nice constraints that were built into the software, and you have to go through all the states and in order to do it correctly, and then people just start finding their own workarounds, right? And this always happens. So of course, somebody says, well, let's build features for that. And again, we have this exactly the same pattern, right? This feature, where does it belong? It starts hooking into all of these things, and sort of there's no clean place to put it. And it gets worse. What happens next? What happens in any kind of system that is sort of responsible for a lot of the complexity?
Returns, cancellation.
I'm sorry? Yeah. So basically stuff going wrong, right? It's failures here, and you get a failure, and you get a failure. So we need to start dealing with this because it's, when something goes wrong and our system isn't sort of prepared for it, then again, people start doing workarounds. So what happens? Well, typical patterns, we need to start audit logs. And that could be something that is somewhere, maybe that's somewhere separate. That's like a solved problem, right? You just sort of send log messages somewhere and it's stored and you can search through it. More importantly, maybe is this kind of context, customer support. So the best sort of customer support system that you can imagine hooks into everything. It allows, so I get a phone call, something went wrong. Maybe the plumbus was damaged. And we need to figure out, or it's the wrong one, or it's the wrong color. We need to figure out what happened, right? So first we need to look into the audit logs. So there's sort of this customer support system, which, well, probably we didn't build it. We just got something off the shelf and started building some integrations with our existing stuff here. But that's sort of what happens. It allows us to look in the audit logs. It allows us to start manipulating things everywhere, right? And when I was doing this presentation a couple of weeks ago at DDD Netherlands, a friend of mine came up with a name for this pattern. He said this is a Octopus Context. So I think we should keep that one. He promised he will blog about it. There's, by the way, if you're interested in that stuff, there's patterns in Eric's book, of course, context mapping patterns. But consider those sort of just to start, the ones that Eric encounters. A couple of people have blogged about other patterns that they found throughout the years in doing context mapping. So it's sort of good to have a name for that, right? It's the octopus pattern. It's something that reaches into all the other contexts and manipulates them. And ideally, it's sort of one-directional, but then you start doing workarounds here and here and here to allow things to happen there, and before you know it, it's all coupled again. So what else do we do? When we have, so we get complaints and we deal with them, but we need to start dealing with them on a more sort of a better solution, that we can keep using across the board. So what do we do if we occasionally get broken plumbuses? We'd rather know about it before the customer complains, obviously. So we need to start doing quality control. And where does that happen? We could do it here, which is kind of late, because when we get an order and then we check if this plumbus is in good shape, and it's not, then we have a problem, because then first we need to order a new one and it takes longer. And so ideally we do it here, right? Something comes in, and we check it. But quality control is typically sort of expensive, right? You have to open the box and get them all out and check them, and you need people there who know what to look for. And so typically you're not going to do it for every single product that you get. That would be impossible. So you're going to start sampling things. And again, it's the same sort of pattern where it starts with people just doing a little bit on the fly, because somebody called from customer support and said, well, every time you get an order from this customer, they're always complaining. So when you get an order from that customer, always make sure, and then it would happen here, of course, always make sure that you check at least 20% of the plumbuses in the order before sending it out. Or if we already know that the stuff coming in here in receiving is going to be sent out to that customer later, then of course we can do the quality control here. And then they start saying, well, from this supplier, so, and then, well, before I go there, maybe this sort of evolves where in the beginning it's just one complaining customer, and we can, tell people and they remember if that's the customer then, or maybe even hard-code it, if customer ID equals. You're laughing because you've seen code that has that exact line. But so, it starts with these sort of quick workarounds, but then we need something better. So we start, maybe our customers even start asking about it, so it sort of becomes part of the contract, where they say, okay, we'll put it in the sales contract that for you specifically, 10% of every plumbus order that you get is going to go through our quality control. So of course we're not guaranteeing 100% of them to be checked, but 10% or 20% or whatever. And that number is here. So now when we do quality control, we need to sort of know, of course, where to get that number. And we need to know the stuff coming in, who that will be for, so that we can link these things. And you see how everything gets more coupled again. And the other side of quality control is that, well, we always get complaints about plumbuses from supplier X and never from supplier Y. So why should we do all this quality control for supplier Y that always provides good stuff? Let's focus our effort on the one that has lower quality. So now we need to, that concept of suppliers was probably not very present in this system before. Now we need to start looking there as well. And we have rules saying, if it's for this supplier or that supplier, we check off or we check at least one per order or 10% of each order, or maybe it's sort of maybe it could be even more advanced, where you get some concept of trust, where you model the fact that this supplier is trusted, and every time we find some some broken product or we get a complaint, then the trust goes down, and when we get a lot of good products, trust goes up, and we can start using that to decide on how much quality control we do. So model that explicitly. Make trust a thing in your domain model, and then you can start manipulating it and have rules about it. So the sort of real example that I'm basing this on, this is the point where I was joining, where I was called in for the first time, and that was like the first case that we were working on. Let me just make some space here. We had this sort of, they were showing me this grid view. So the original system was very sort of crud, where everything is just a grid of things, and then you click on an item, you get a detail screen, and you can change some data. Very sort of, not really, the domain is not really modeling the user interface. It's just, here's data, here is forms, that sort of thing. And so one of these forms was, well, it was actually for, it was used in receiving. And it has, incoming shipment, and there's probably some IDs and some information about, description and quantity, that sort of thing. And at some point, somebody said, well, we need a new feature. If they come to you and they ask about a feature, always ask them what the problem is, but that hadn't happened here. So they just asked for a feature, and the team had built it. It was adding another column saying quality control, and there had to be a number in there. And that's this number of items from a specific shipment that or package that we need to check. So if it's 10% and there's 50 in there, that number would be 5. If the rule is, because of one of these things I discussed, if the rule is 1 per package, then the number would be 1 here. So, but this view was the receiving view. So this is incoming shipments. This was not a specific view for quality control. So why is this quality control column in there? So that's when we started sort of reverse engineering how it was, as always, a legacy system that they inherited, and all the original developers had long gone. So we started sort of reverse engineering of why that column was here, because it didn't really make sense to us from a DDD point of view, I guess. And what happened, once again, same pattern, it was sort of human optimizations, because they didn't have a quality control department with people who sat there all day doing quality control. What really happened, of course, is that this sort of emerged from needing it, and what they simply did was having some people that they would allocate to quality control based on how much they needed it, right? So it would be just people from receiving, and maybe even people from elsewhere that would say, okay, go over there and check 5 items from that box and see if if there's any problems with that, and flag them if they're not, and etc. So it was really just again an optimization thing. I want to know in advance how many people I will need to move to quality control while I'm organizing, in order to organize the workloads and the schedules of my people and capacities, that sort of thing. So what would have been a better solution is probably that they would have a separate screen where it would not tell you how many items, because so basically what happens is they look at this and they just add up the numbers and say, okay, well, today, based on the incoming shipments, we'll have 20 items that need to be checked, so I more or less know that one person can do 3 per hour, so I need to put this many people on there if I want it to go out in time. And then, of course, we start automating this thing again, and we start, well, at least that would have been a better solution where instead of showing these numbers and letting the floor manager do the optimization, have a different screen where we say, well, tomorrow you need 2 people on quality control for 3 hours, that sort of thing. But that's not what happened. And what made it worse, and that was even more interesting, I think, to me, that column was actually empty. For some technical reason, this was like a feature they added in a hurry, probably, because it was not in the backlog, but suddenly they needed it very urgently. And so what happened was, in this view, you had to select a shipment and then click the confirm button, and then this number would appear. So confirm means we received the shipment and it's all good, right? So the truck came in, we unloaded it, we looked at it, this matches the order, we put it on the conveyor belt to go into the put away thing, and check, right? The way you would mark it off on a paper form, here you would select it and click confirm, which is, that's fine. But the weird thing is that the number only appears when you click confirm. So of course what's starting to happen right away, you can imagine this, right? You've seen this sort of thing. People would select the item, click confirm, the number appears, click unconfirm. Because it was not actually here yet, this wasn't received yet, but I wanted to know when it will be received, how many people will I need to put on that thing, right, for quality control. So, and it's just a workaround, don't worry about it. We just click confirm, we have this new unconfirm button that we have been asking for a year, and finally we get it, so we can use this as a workaround. So who knows what's going to happen next? No idea? Anybody in warehousing or logistics, or what's the big trend now? Robots! Yes. So we buy this new automated warehouse. It's these huge robot arms that grab a thing and move it somewhere to a conveyor belt, and some other arm grabs it and puts it there. And so what do you think happens in this CRUD view that is not built with the DDD mindset? And you just select an item, and you click confirm, and then all the robots start moving, and then you click unconfirm, and the robots are confused. And so, and then of course the whole automated warehouse thing is in there everywhere. And I recently learned this expression. I think it's American, paving the cow paths. Am I saying that right? It's where no? Okay. Paving the cow paths? Yeah, okay. At least somebody has heard of it. So it's this idea that all the things, so the paths that the animals have been using, we turn them into the actual roads. Not because they're the most efficient or whatever, but just because they're already there. So this is sort of what happened here. They added this automated warehouse, and basically they encoded all the workarounds that they had been doing that were really optimized for humans, and for all the little things that they were doing, and just sort of that landed in the code. They started automating it, and they're still doing all these same things, even though they're hugely inefficient for robots who don't make the same kind of mistakes that humans do. So so now the coupling is even worse, because that's you don't expect to replace your robots every couple of months or so. So you're hoping to build this. And so where's my pretty picture? It was in there somewhere, but so I have some So if you were hoping for the one true answer that will solve all your problems, I'm sorry that's not in this talk. But we can offer some heuristics and some ideas to start thinking about these kind of problems and hopefully preventing them. So one thing that I think is very often happening is that you talk to domain experts and you think that you build a coupled system, not just because it's coupling in the code, but the coupling was already there in the minds of the business, in the minds of the expert. They have never bothered to think about things in a sort of highly decoupled way. They just, okay, we do this thing, and then this person from customer support calls this person on the floor to tell them, oh, by the way, if you get the order from that supplier, move it right away to, all these kind of things. They never thought about this as coupling. They just thought of them as quick, easy solutions to their problems. They have never learned to think about their system in a sort of decoupled way. So it's our job. When people say we model the domain, that's not enough. You'll just copy the coupling that they already had in the domain. So you have to not just model it. You have to tear it apart. You have to deconstruct this domain and start seeing this again as what are sort of independent things that we can do. Can we sort of conceptually at least decouple it in our minds and then start seeing where the pieces need to fit together and where we can actually have looser coupling between all these areas here. So I think that's sort of the first sort of mindset that you need to have, that the coupling is not just a software thing. It's really a domain thing. It's just how humans work. We're not used to thinking in that sense. The same way that your business people have never learned to think about ubiquitous language. They just use language and it grew organically. And they have duplication and nuance and ambiguity. So it's our job. In a sense, what I think is when you're doing DDD, you have to model things in a more precise way and than anybody else in the business does. Because, well, they say the whiteboard always compiles, right? You've heard this expression. So when business people model something, they don't need to be precise. Not the way that software developers need to be precise. Because if we're imprecise, the code is just not going to work. If you have a type system, it's not even going to type check. So, in a sense, doing DDD is a way for the business to think about itself in a more precise way than they would normally do. I think this is one of the powerful things of starting to worry about language and obsess about language, the sort of healthy obsession with language that DDD has. Start thinking about models and start thinking about separation and boundaries and context and how this messy language where the meaning depends on whatever is surrounding that, to sort of find a way to maybe not solve it, but make it manageable, right? That's what these contexts are. So if you approach problems like these from the start with this mindset, no time like today, so even if you didn't do it from the start, it's not too late to start thinking about it in that way. I'm sort of running out of time, but I'll try to touch on some things as well. We can start, how should I put this? We can start organizing it a little bit different. So we've been very focused on how this business is used to working in this sort of linear way, stuff coming in, putting it away, and outgoing. But there's other ways of looking at that. One could be, I'm not saying this is the one true answer, it's just one way to look at things. So let's imagine that this is our actual processes for deciding on quality control. So it could be, you can imagine something that was event stormed, or it's more, you can imagine it as a decision graph. So a bunch of decisions are being made, and in the end, we know sort of the number of items that need to be quality controlled. So if the contract says that 10% of items need to be checked, but it's a trusted supplier, but we've had a complaint. However, it's an expedite. And so basically going through this whole decision-making process to end up with this number here of items that need to be checked. But then we model the process independently of the decision-making for that process. And I'm rushing through this, but hopefully it will trigger you to read the end of the book by Eric. That's where this stuff is to be found. So all of this stuff that I was mentioning, so basically expedites from here, and sales contracts, and forecasting, and this concept of trust. So we're sort of modeling the decision making, even if we're not doing this like in our implementation, just sort of conceptual modeling, just trying to reconstruct. So we deconstruct everything and we reconstruct it instead of vertically in horizontal layers, and saying this is the process, this is each of these decisions in the process happening based on this thing here. And then the next sort of thing is, what are the inputs to these decisions? For example, here it could be, so it could be more like this, and then here so here is the decision logic, and here is the system where we get our input from. So maybe there's an ERP system here. Could even be things like, maybe there's like government regulation. So maybe we have something here that manages that, and that says, if it's like food products or something are heavily regulated in Europe, so how long can this be out of the freezer, that sort of thing. So that could be here. So this is sort of all the inputs that we have to our decision making. So instead of looking at this as this sort of structure that we had here, we're now sort of turning it sideways and saying, well, here we're doing everything that is the whole process of that, and here we're doing everything where we're managing or we're modeling these decisions, and this is the data coming in for that, right? Is that making sense? I'm just rushing, but and you actually know these. So basically, going from here to here, and from here to here, those are patterns that you already know, right? We have. So this, by the way, is called responsibility layers in Eric's book. So let me just put that here. But so this is really just a strategy pattern, right? It's these become sort of replaceable strategies. They're sort of polymorphic. So we can start managing the order of the process separately from the actual decision making by simply putting another strategy in there, or replacing them, or if we need to start changing here, we don't need to touch this. We could just change the rules here, or vice versa. If we want to keep the rules but we want to change the order that they're applied, we only have to touch this system here, right? So we get this sort of conceptual decoupling that I'm looking for. And this pattern here as well, you already know this as well. This is adapter pattern, or anti-corruption layer in the blue book, where these models here are kept very clean. They're not impacted by all these other third-party systems here that we're integrating with, and these APIs, etc. We have a little layer in between that says everything that comes in here, we're translating it to our own clean language and our own clean model, so that this doesn't get corrupted, and this definitely doesn't get corrupted, right? So you already know this kind of thing. Is that making sense to some degree? All right. So again, I'm not sort of saying that this is the true answer to solve all your coupling problems, but I'm trying to get you to, when you do some modeling, try to find another way of looking at it. I recently learned a term, it's multi-perspective modeling. Abraham Pupko is going to do a talk about that at next DDD Europe. But it's basically this idea of, all models are wrong, some are useful. So how do we get to the useful model? Well, make more models, right? Make more variations. Force yourself to look at your thing from a whole different point of view. What if we look at it from, instead of just our sort of domain concepts like receiving, let's look at decision-making and process and separate that. Or let's look at, maybe this could be operational and decision-making. And in fact, I think the example in Eric's book goes even one step further and says there's sort of operational decision-making, and then there's policies. And we could even separate those. Maybe for this domain, it probably wouldn't make sense. But this kind of thing where, maybe you have sort of official policies for the whole company, but then you have local variations where people can decide things on the fly or based on inputs, and you could even separate that. Another heuristic that we can use is start looking for how fast does something change, right? What's the rate of change? And start pulling it apart based on that axis. So, there's a bunch of sort of local decisions that change all the time where it's just sort of day-to-day operations where people make decisions about stuff. That has a very fast rate of change. Stuff coming in and going out a couple of days later, that's very fast. Areas that would be slow is, well, the robots, for example, we're not going to replace those machines every couple of weeks. So that would have a slow rate of change, a very slow rate of change, maybe every 30 years. Government regulation would be somewhere in between, where it changes every couple of years, and it's usually announced like half year in advance, and starting January 1st, here's the new rule for handling frozen plumbuses or whatever. I don't know if you can freeze them, but so basically, rate of change is a very good almost predictor of where good separation of context could lie, because things that change together, we want to keep them together, and things that change separately, we want to keep them separate. And if we look at the rate at which things change, then that sort of predicts maybe how much they will change together, if that makes sense. So just look at again, make a new model and say, well, what if we ignore everything we did? Wipe the whiteboard, throw away the model, start over, and let's model from this point of view of rate of change. Do we learn something from specifically modeling rate of change? Or throw it away again and say, well, let's look at the source of change. Maybe that's a better predictor even. We don't know, but at least modeling is cheap. We don't do it enough for something that is so cheap. If you build something that's expensive and it goes into production and it was wrong, it's going to be very expensive to change it. Spending half a day on the whiteboard with some Post-its is very cheap in comparison, except that there's some project managers sort of looking over your shoulder and saying, shouldn't you be coding? If you're not typing, then you're not working, right? Then you're not productive. That's, of course, that's a culture change. That's a topic for a different talk. You can't do DDD if you don't change the culture for it. But that's sort of what I was trying to get at. So basically, what I would like to say is look for local decision making, right? If here this little thing here can do all the decision making related to expedites, and the thing that knows the states of stuff and makes decisions about those states, if we can bring that together, that's probably going to make for a more stable boundary. I'm not saying it's a hard rule, I'm just, again, offering heuristic. This is not a new idea, this is object-oriented programming. Let's move state and behavior close together. This same concept works for microservices, it works for bounded context, it works for bigger ideas or bigger concepts as well. So local decision making, that's a good thing to start looking at. Avoiding this sort of speculative analysis where upfront you're saying, well, this is what our system is going to look like, this is what our boundaries are going to be, and let's just hope we're right. It's of course hard and expensive to change a system later, but if you build it under the assumption that you will be wrong, you will be more careful in sort of this, what kind of things you build that are hard to change later. You will be more aware of that. Let's just put it like that. So no big design up front, but big discovery up front. Definitely do this sort of sprint zero sessions where you get everybody in and just make it like a couple of days workshop and do event storming and do different kinds of modeling and try to find everything that will possibly go wrong in the future. And there will be people there saying, yeah, but we don't need that now. We're agile. We're just going to build the one thing. But those couple of days of just exploring, how far could this go? What if, putting pressure on the model, what if we have, if this happens once in a million times, but we grow and we have 1 million users, then this happens every day, right? And then we care about this. So do this sort of big upfront discovery. The multi-perspective modeling that I was already saying. Try, I had at one point I was working with a team and we had a Kanban board, and at the bottom we made a a place where we would put sort of slogans of things to remind ourselves. And one of them that was on there was find at least 3 solutions. And we made a point of that every time we would have a meeting or discuss some problem or do some modeling, even though we would think, okay, this looks great, this is what we're going to build, stop, find 3 solutions. Wipe it, find another one. Force yourself to find a different way of looking at it, and then again. And 9 out of 10, you're going to end up back with your first solution, and the angry project manager is going to say, why did you do the 2 other models? Because the first one is the one you're using. Well, the 2 wrong ones confirm that the first one is probably the right one, right? And probably you learned some things and you picked up some things and you make like a mashup of the 3 solutions. And at least you have something to do trade-offs, right? So that's what I wanted to say about this. Any questions? Was this making sense to some degree? Yeah. I can't see really well with the light, but okay. Well, I guess you're all in need of some coffee, so thank you for listening.